So a student has a selection of a rubber band of different widths, and he's investigating the extension produced by adding a load. So how we carry out this investigation? So we place a meter rule or a ruler next to the rubber band, and we measure the original length of this rubber band. Then we add a set of masses, or we add a load. So when we add a load, the size or the length of a rubber band will change, and we will measure the final length. To calculate the extension, it is the original, the measured length, the final length minus the original length. And we will repeat the procedure by adding more loads and when with different types of rubber band or different widths of rubber band. So this was a planning of this experiment, how you carry out your investigation, the procedure you have to mention. State key variable that you would control. What you will control in this experiment, the variables for a fair comparison. What variable we should control in this experiment? We have different thickness of or width of a rubber band. What else should be say? The load, the set of loads which we are using, the material from which a rubber band is made, original length, the original length, the material of the rubber band, then set of loads. They all should be same. Draw table or tables with a column heading, how you display your readings. So how we display our readings? In this experiment, we are measuring the original length and we are calculating. So we add a load. We measure the new length and we calculate the extension. So load, or you can mention force. And when they mention it, that you have a like table with a column heading, it means there should be units as well. So force is there and the unit is Newton, or load L is there, unit is Newton. Length is there. Normally extension is measured in centimeter practically, so it will be centimeter rather than meter. And extension, it's calculated also in centimeter. Centimeter or millimeter are the practical units for extension or calculate change in length. Reason for that, because the substance or the rubber or the spring will not show change in length, considerable change in length in meter. So that's why we use centimeter or millimeter. Explain how would you use your result to reach the conclusion. So how you can reach your result? You can plot a graph. You can plot a graph between force on y-axis and extension on x-axis, and the rubber band, which shows a steeper slope, is difficult to stretch, and the rubber band which show a smaller slope or smaller gradient is easy to stretch. So you can identify by using the slopes. Is it clear, discussion? Planning of experiment to investigate how we can identify or how we can relate force with extension and identify which one is easy to stretch and which one is difficult to stretch. Page 13. Use the result to predict the load L. That would give you twice. So for this, you should have a graph. Just a minute, I will share the graph with you. So length of the spring when nothing is attached, you will measure this length. Here in this one, it's 13 millimeter. But maybe the marking scheme answer might be different from this. Reason for that, because your paper size is different from the exam paper size. So the measurements are not equal. So it's not an issue. The idea is you should be able to measure from the figure. So when nothing is attached, no load is attached, the length you measured, example, it was coming out 13 millimeter. So in the next part, they're asking, use your result, predict the load when the length is twice as the original. So if original length was 13, then twice of original length will be 13 multiplied by 2 or 2 multiplied by 13, which is equals to 26. So you will draw a line from 26. When the length is 26, draw a line and then find the load. And that will be your answer. Is it clear? Any doubt in this? Page 9. Another spring with a smaller value of a K. The limit of proportionality of a spring is reached at extension of 50 millimeter. Continue on the graph to show how the spring behaves. So continue on this graph how the spring, as you are adding a load, extension and load are not directly proportional, so it will turn into curve. And force and extension graph, the slope is equals to K. So they mentioned draw for another spring which is having smaller value of a K. So smaller value of a K means smaller slope, less steeper. So it will be below this. This is the answer for question number . On page 9. Is it clear now? Page 4. You mean page 4 or question 4? A student is investigating the stretching of a spring. On the figure, measure the unstretched length. You have to measure this length using a ruler or a scale. You will place a ruler or a scale next to this. and measure this length and add that value to a table. For example, when you measured it, if it's coming out say 10 millimeter or 20 millimeter or 30, any number, you will write here. Example, if it was 30, I'll write 30. Then how to calculate extension? So just the difference between the two values. If originally it is 30 and new is 59, so 59 minus 30, that's equal to 29. Same thing, 64 minus 30, that's equal to 34. So you will complete this table and then plot the graph. Any other question? Then the other part is you have to plot the graph and then solve according to the graph. So I'll end the session now and share the recording with you.